All right, so today we're looking at conditional probability, and we're talking today with two-way frequency tables. So kind of taking what we did yesterday and adding a special stipulation on our events. Okay, conditional probability contains a condition that may limit the sample space for an event. Okay, you can write a conditional probability using this notation, the probability of A with that line, and then B. The way that we read this is the probability of event A given event B. Okay, the key word here is given. So down here is the formula. The last bullet point here is the formula. And on Monday we're going to talk more about how to use that formula. Okay, but what you want is the probability of A and B, so the probability of both things happening. But then you're going to divide by not the whole sample space, but instead whatever the second portion of your probability statement is what's going to be on the bottom. Okay, that's where the condition comes in, the limited part. So let's look at our first example. Okay, the table shows the results of a class survey. Find the probability that someone owns a pet given they are female. Okay, we need to find the totals on the table. They didn't give those to us. So I'm going to add up this stuff here. 8 plus 5 gives me 13. 6 plus 7 is 13. 8 plus 6 is 14. 5 plus 7 is 12. The total in the table would be 26. All right, so again, we're trying to find the probability that someone owns a pet given they are a female. So the condition female is going to limit our sample space to just the outcomes of females, which is 14 possible outcomes. Okay, this is the probability of B. So, of the 14 females, okay, we go to how many own a pet. So, females that own a pet, there are 8. So, of the 14 females, 8 own a pet. This is the probability of A and B. All right, so therefore, the probability someone owns a pet, given they are female, is going to be on top the probability of owning a pet and female, which will be 8, over the probability of female, which is 14. 8 over 14 will reduce, always reduce your fraction, and it would be 4 over 7. All right, so looking at the last example on the front, it says the table shows the results of a class survey. Find the probability that someone washes dishes given they are male. Okay, so once again, we need to total up our table here. Okay, so 7 plus 7 is 14. 6 plus 8 is 14. 7 plus 6 is 13. 7 plus 8 is 15. The total for the table will be 28. If we're looking at the probability that someone washes dishes given they are a male, okay, we want the probability that they wash dishes and male. So wash dishes and male would be 7 over the second half of the statement tells me they are males. So I go to the total for male, which is 15. So my probability would be 7 out of 15. So taking a look at the back here, it says using the data in the table, find the probability that a sample of not recycled waste was plastic. Okay, so this time we got to kind of fill in on our own. We got to decipher what the question is asking. Okay, so find the probability that a sample of not recycled waste was plastic. So rewording this tells me I'm looking for the probability of plastic given it was not recycled. All right, once again, I need to total up on this problem here. Okay, so for the total for paper, I have 83.8. The total for metal, I have 16.6. The total for glass is 12. The total for plastic is 21.5. The total for other is 83.1. The total for recycled is 60.7. The total for not recycled is 156.3. The total in the table is 217. All right, so if we are looking for the probability that a sample is plastic given it's not recycled, I want the probability of plastic and not recycled, which is 20.4, divided by the probability of not plastic, which is 156.3. All right, so looking now at the next example, it says a poll was taken at Alexander High School that asked students in each grade what their favorite subject was. The poll generated the following frequency table. So we're looking at 9th, 10th, 11th, and 12th grade, and then math, English, science, and history. Okay, and they totaled for us this time. So A asks what is the probability that a student likes math given they are in the 11th grade. Okay, so we write it down using the notation. So probability of math, and then that bar given. They are in 11th grade. Okay, so I'm wanting the probability of math and 11th grade. So math and 11th grade is 205. Out of, divided by, the total for 11th grade. So I go all the way across to 603. All right, so the probability that a student likes math given they are in 11th grade will be 205 out of 603. Looking at question B, we've got what is the probability that a student is in 10th grade given they like science. Okay, so probability of 10th grade given they like science. So I want to go to the table where I have 10th grade and science. So 10th grade and science is 200. The bottom part of my fraction is going to be the total for science. Okay, so total for science is going to be 383. So the probability that we pick a student that is 10th grade given they like science is going to be 200 out of 383. Looking at the last example on the back here, they have us looking at a Venn diagram, using that information to fill in the table, and then we're going to answer the questions about it. Okay, so the Venn diagram shows the number of students that exercise in different ways. Construct a two-way frequency table that displays this data. Okay, so we've got jogging and aerobics. Those are my two categories. Okay, so on the side here, I'm going to put jog or no jog. Across the top, I'm going to do aerobics and no aerobics. And then I have my totals. Okay, so from the Venn diagram, I'm going to use that information to fill into the table. All right, the first box is for jogging and aerobics. So that is the overlap of my two circles, which is 8. The number of students that like to jog but not do aerobics would be 24. Okay, the people who do not like to jog but do like to do aerobics is going to be 13. And then no jog or no aerobics is going to be 5, the ones outside of the circle. Okay, so we're going to total it up. 8 plus 13 gives me 21. 24 plus 5 gives me 29. 8 plus 24 is 32. 13 plus 5 is 18. The total in the whole table will be 50. All right, so A asks, what is the probability of students who go jogging? So I'm going to take the total number of jogging, which is 32, out of the total in my table, 50. So this is a review of yesterday's notes. Reduce your fractions. 32 over 50 will be 16 over 25. Question B asks, what is the probability of students who do not jog or do aerobics? Okay, so these are the 5 who do nothing. So 5 out of 50 reduces to 1 out of 10. So A and B are similar to the questions you saw yesterday. C asks, what is the probability of students who do aerobics given they jog? Okay, so this is where conditional probability comes in. We're limiting our sample space here. So we want the probability of aerobics given they jog. Okay, so I want the number of people who do aerobics and jog, which is 8, out of the total number for jog, which is 32. 8 out of 32 reduces to 1/4.